大家或许还记得2016年的那场震惊世界的对弈 ，DeepMind 的 AlphaGo 成为了第一个击败围棋世界冠军的人工智能。它的成长过程堪称 AI 史上一个转折点。它先学习人类的棋谱，掌握基本下法，接着开始自我对弈，每天和自己下上百万盘棋，不断根据输赢信号优化策略。最终，它发现了人类从未想过的走法，成为了第一个击败世界冠军的 AI。如今，从推荐算法到自动驾驶，从工业控制到智能体训练，强化学习都在悄悄成为 AI 进步背后的第二引擎。当大力出奇迹式的 AI 发展范式碰壁，强化学习成为了各大 AI 巨头接下来的救命稻草，被认为是接下来人工智能到达 AGI 的关键技术。然而，最近在 AI 业界也是不少人开始质疑强化学习的路径，就包括了 OpenAI 的联合创始成员 Andrej Karpathy 在最近接受播客采访的时候公开表示，他认为我们距离 AGI 的实现仍然有10年之遥。强化学习虽然优于此前的技术，但是本身效率低下且充满缺陷。所以，研究强化学习路线的 AI 科学家们是怎么认为的？他们正在研究什么样的技术？强化学习领域目前最艰难的挑战又是什么呢？在今年的10月5号，硅谷101举办的 Alignment 2025峰会上，我们就非常荣幸地邀请到了4位分别在 OpenAI、亚马逊、前 Meta 以及 LinkedIn 的强化学习领域的重量级嘉宾与我们一同剖析这一前沿领域的最新进展与未来的发展方向。那因为这场在硅谷的大会是全英文的，我们将内容翻译成中文分享给大家。那这场 panel 可以说是真的非常难得，是强化学习领域最顶级的 panel 之一了，希望对大家有所帮助和启发。Enjoy.
It's all right. All right. Hope you guys have a great morning so far. So I'm honored today to have a wonderful panel with me today. In fact, all of them are my friends to some extent, like for the last many years. I've known each of them for quite a few years so far. So it would be great to have this opportunity to also reunion with all of my friends here. So we're going to focus on RL today, and we all know that reinforcement learning sort of is core to today's AI advancements. From earlier this year of DeepSeek's release of R1, where they have reinforcement fine-tuning to really have some sort of self-improvement on coding and math, to later this year where we see a lot of applications on math, coding, chemistry, physics, even embodied AI type of applications on reinforcement learning that enable really strong intelligence. And we've seen a lot of RL companies that raise a lot of money as well. So we're going to dive into all of that today. But before that, I'd love to have the panel introduce themselves. Maybe start from Lihong. Yeah.
Hi, sure. Yeah. Hi, everyone. My name is Lihong from Amazon. I work on reinforcement learning and language models for a while, and then it's a pleasure to join the panel. And thanks to the organizer for inviting me here.
Zheng?
Yeah. Hi, my name is Zheng Wen. So I'm currently working at OpenAI, and before that I was at DeepMind. So I also work on reinforcement learning, and actually I'm a big fan of Lihong's paper, and also working on large language models and AGI in general. I'm very happy to join the panel today.
Good morning, everyone. I'm Albert Garamifard. I'm a distinguished scientist at LinkedIn, mostly focusing on agentic RL. Before coming to LinkedIn, I was at Meta, where I was actually working with Bill closely. And before that, I was in Amazon Alexa.
那如果我们从头看人类的学习其实经历了3个阶段。那最早的我们通过模仿来学习，看到别人怎么做就照着做。那后来呢，我们开始总结规律，知道什么样的做法更加容易成功。而真正的智慧来自于第3个阶段，也就是我们开始自己去试。人工智能的学习之路呢，其实也是这样的。最早的 AI 只会模仿，它靠大量例子去复现人类的答案。之后呢，机器学习让它能够从数据里面自己发现模式。比如说呢，看到几千张只猫的照片，就能够分辨出猫和狗。但是呢，那还不算真正的会学。真正让机器学会思考、学会决策的是强化学习。那强化学习呢，让机器有了行动与反馈的回路，它不是被告知答案，而是呢通过行动获得结果，再根据此来调整，做对了就得到奖励，那么做错了，下次换种方法。那么听起来很简单但是这就是人类学习的本质。 所以呢，我们可以说，强化学习是 AI 从被教会到自己领悟的那一步。到那一步之后呢，机器不只是理解世界，而是开始在这个世界里学习如何行动。
That's great. Cool. So let's dive right in. I think people, if you guys know the recent advancements in reinforcement learning, one thing that has been like triggering a lot of interest so far is how can we train RL agents in language models without actual supervised data? That is, that there's no human labeling, there's no human expert annotated data, and how do you train these models? And one of the trends is RLVR, reinforcement learning from verifiable rewards. The idea is that you can literally use rules and sort of like verifier systems from math to really verify whether or not the outputs of certain language models are correct. So the first question is, there's a lot of papers coming out recently on RLVR, and then this is sort of almost like a consensus on how these things are going. So where do you guys think like RLVR can go beyond like just current reinforcement fine-tuning on math and coding?
Yeah, I think it definitely has a lot of great impact in parts. But on the other hand, we also see that the many problems are not verifiable. They don't have verifiable outcomes. So I think that at some point there is a need to go beyond that to handle non-verifiable problems. An example is that when we are children, we are learning in school, we have tests that are verifiable. They have verifiable results, right? A, B, C, D, choose one of them. But then when we actually go out to work, and it's hard to say that you have to do this in order to check the mark, right? There's a lot of high judgment call and non-verifiable outcomes that we have to explore, and so that's a much fuzzier place. So I think that's where we need to do more beyond verifiable rewards.
Yeah, I think for reinforcement learning with verified reward, my understanding is that this approach can be used in a very general paradigm, which is you generate first and then verify. And the reason is that usually it's much easier to verify than generate. I mean, if we think about whether or not it can go beyond fine-tuning, I think it can. And actually, there are already some work on that. For example, you can use this approach to develop stronger reasoning skills. And you can also use it in somewhat different framework compared to fine-tuning, like, reinforcement learning based on debate, or reinforcement learning based on self-critique. I think all of these go beyond fine-tuning.
I agree with all the points raised. I think reinforcement learning kind of give you the capability to just go beyond of what a tutor or a mentor basically shows you and says, hey, this is what I want you to maximize. And I think we are there on the cusp of how do we define this goodness or the cookie for the agent. And verifiable rewards are definitely like a way to go because it's very crystal clear how to define them. But many of the tasks, I think, requires a combination of both. There are things that we know that has to happen. If you're compiling a code, we know that the code should be built successfully. But there are things that we actually don't know exactly how to define them. Like if you're writing a summary or if you're providing an innovative idea, how innovative it is or how good is your summary. And I think that's where we need to get inspiration from humans essentially to guide us to how to shape this reward function. And there is a lot of a litany of work of starting from like comparison and alignment, DPO, all of those algorithms, all the way to now getting like richer, using LLM to become essentially a judge and fill the shoes of humans for those cases.
Yeah, I think we're alluding to the next question basically where reward design itself might not just be completely verifiable. It might be like designing a mixture of like verifiable reward with like human feedback and alignment type of rewards. But one of the things that is puzzling a lot of researchers and also production people is that like, what is sort of the golden standard here, right? Because if you have verifiable reward, basically you don't need data. But then if you have sort of RHF type of information where you have human feedback as one of the judgment, then you actually would require a lot of data for human feedback. And then for very complex tasks like trying to solve a level sort of chemistry Olympics or physics Olympics type of questions, if you guys don't know, like a single data annotation on a response from a language model takes about $20 from a PhD. So where do we cut? Like, how much data do we need? Is there a way that we can handle this mixture of verifiable and non-verifiable reward without actually data? Maybe this time we can start from Albers.
那到这里我先介入一下啊，那其实 Bill 提到的这个问题呢，背后还有隐藏着一个更现实的挑战，就是我们到底在用谁的数据来训练这些系统。那过去几年我们看到像 Skill AI、Search AI、Merker 这样的公司呢，都在为这些人类反馈提供标注数据。但是呢，行业正在发生明显的转变，人们开始意识到 AI 不再需要廉价重复的人工标注，而是需要专家级的数据，来自博士、研究员或者真正懂业务的专业人士。那比如说 Merker 的做法就很典型，他们不再雇佣大规模的外包团队，而是邀请奥赛的选手、博士生、工程师来给模型打分。那么这样做的成本确实是更高的，平均报酬呢是大约每小时95美元，而一些传统标注公司的报酬呢约是每小时30美元，但是呢，这样带来的信号质量、模型稳定性却远超传统外包式的数据。那么这也解释了 Bill 所说的黄金标准难题。在未来的强化学习当中啊，我们也许不再追求更多的数据，而是追求更好的判断，而判断的价值往往呢是来自于懂行的人。那么接下来呢，我们就再来听一听几位嘉宾怎么看从可验证奖励到人类反馈这条路该怎么走。
Sure. I think we need both. In reality, we want to be cost aware. So humans' judgments are expensive, as Bill mentioned as an example, $20 per sample, and you need like gobs of data. That would be like, making your bank account break. So we want to make sure that we are using it judiciously, but we can't just also ignore that, because for many of the tasks, we actually don't know how to create this reward function. So it's more like think of it as an active learning situation. So you can create essentially a mechanism to gauge your LLM judges. So you can get, like, let's say 4 of us here decide about like a small set of data sets, how we actually gauge those and measure those. And if we all agree, then this can be a rubric to then go and check LLM judges and see, do they comply with our agreement? And if they do, then it can be a blessed, now low cost, essentially non-verifiable reward that you can apply on the masses of data. And then you can close the loop through like active learning. If there are some areas we can occasionally go and see, are you doing the right thing? And if there is like some holes over there, we have to go back and it's like, hey, let's collect some data in this area, make it better, and then go back and apply it.
Yeah, I fully agree. So I think, there might be 2 ideas to handle this. Firstly is that we might try to decompose the problem a little bit. Because even for a whole problem, maybe it's not verifiable, but maybe we can decompose it into some subtasks. And for some of the subtasks of some of the steps, it's verifiable. So that basically can already partially solve the problem and make the problem easy. And another solution is obviously to keep human in the loop. And also that's why we do reinforcement learning from human feedback. I think that if in this case, exploration is very critical. The reason is that because it's so costly, so you want to identify the right expert to ask the right question. So this clearly requires a very effective exploration algorithm.
Yeah, these are the great ideas, and I just wanted to add that there's maybe another possibility of looking at the stream and experience of the model, right? Where the model can rely on its own capabilities or external models' capabilities to extract signals from this experience, stream of experience, and do learning, right? And then at the end of the day, I think there's something that's maybe too obvious to say, is that the capability of the power of RL is limited by how good a simulator is, how good the environment you use to train the system, right? So I think depends on how, all these are great ideas, but I think at the end of the day, we need to make trade-off on how to make sure the environment is of high quality.
那么接下来呢，我们会聊到强化学习中的探索这个主题啊。那这里解释一下，在强化学习 RL 当中呢 ，agent 通过与环境交互来学习，然后呢，它的目标是最大化长期累计奖励 reward。 那在这个过程当中呢，一般存在着2个核心策略的维度。那第一个呢叫做 exploitation， 就是说利用已有的知识选择目前看起来能够获得最高奖励的行动。那第二呢叫做 exploration， 就是这里说的探索，尝试新的尚未充分了解的行动，以获取更多的关于环境的知识。而这2者之间的平衡啊，被称为是 exploration-exploitation trade-off。而刚才呢 OpenAI 的正文提到的探索 exploration， 在强化学习当中啊，其实指的就是智能体主动的去尝试新的行动或者策略，以发现潜在更优结果的过程，而不仅仅是利用已有的经验。那么在嘉宾提到的场景当中啊，因为与专家交互的成本非常高，那么探索实际上意味着要高效的决定问谁、问什么问题。因此呢，一个有效的探索算法并不是盲目试错，而是在代价与信息增益之间找到最优的平衡。
I might want to actually dive into it a little bit because we mentioned a couple of really good ideas. One around exploration, the other around like rewards that's like a mixture of different types of rewards and sub-problem like breakdowns. There's a bunch of ideas that surface. I want to like touch on exploration first and elaborate on that a little bit because I think everyone on this panel actually worked on exploration at some point in your career. This is one of the topics that a lot of RL people are today not focusing on enough because you see the PPO algorithm, GRPO algorithm, DPO algorithm, they're fine-tuning an existing model that has already been trained in a collapsing modality. And then exploration is really needed when you actually have like little information about the environment and trying to explore and understand like what's the most important part of the equation. So the question for Jen is like, where do you think is the balance between pre-training and post-training when you actually really want to induce like strong exploration behavior?
I think we want to make sure that during the pre-training, like when you're doing the pre-training, you have a generally good model across a wide set of tasks. If you start seeing that you're getting better in some of these tasks but worse in some other tasks, you're doing it too far. And I think that's the part that you have to delegate that to the post-training essentially stage. From my perspective, the main role of the pre-training is to have a model that has a good understanding of fundamentals of the basics and the key ingredients of how to solve these problems in a higher level. And then have the post-training, you can fine-tune on a specific task that you actually care about it. And I think that's the breaking point to me. It's like you can look at your evaluation across the board and see if you start regressing on some of these models in these domains compared to the other ones.
Yeah, I fully agree. I think that usually pre-training is a step where you acquire the general knowledge. So you want your model to be expressive and roughly understand the world. And post-training is you want to adapt it so that it can become an expert in some field. I also want to mention that I think the exploration is crucial in cases where the data acquisition is very costly, because here you cannot really acquire a lot of data. So you need to want to doing exploration to make sure that you acquire informative data. It's also important in cases that not every human or every reader can give you some useful feedback. So in that case, you also need to explore to identify an expert from which you can get the useful and informative feedback.
For exploration, I think that today's exploration is very different from what we used to talk about exploration. And when pre-training is done, I think the space of exploration is already very limited. Right? I think the goal there is just to make sure the model has a good starting point and to get a good trade-off between how good you train and how fast you can train the model in post-training. At least that's my understanding. But I think for real or more aggressive exploration, it may be interesting to look at beyond the token level or something that has more high level and do exploration there and then combine that with the token level exploration. I think that may allow the model to think out of the box or maybe more aggressively in the post-training process.
Yeah. That's great. I think that alludes to both questions of like higher level abstraction and also hierarchical planning. So if you guys haven't heard Rich Sutton's latest talk about the OaK architecture, it emphasizes a lot about an hierarchical structure of options, and then also sort of like lower level planning on top of that. So the idea is that you can actually break down very complex tasks into like subproblems, and then each subproblem can be solved by some level of planning inside a sort of world model, and then outside you actually can sort of learn by experience.
那简单补充一个背景啊，背后提到的 OaK 架构呢，就来自于 Richard Shadon， 他被誉为强化学习之父。Shadon 奠定了现代强化学习的核心理论，比如说时间差分学习 TD Learning 和价值函数 Value Function。2024年呢，他还获得了图灵奖。那么今年呢，他是提出了 OaK 架构，全称呢是 Options and Knowledge。正如贝欧所说呢，这个架构呢非常强调选项的分层结构，以及在此基础上的低层次规划。那么通俗的来说啊，就是把复杂任务拆解成为子任务，每个子任务内部呢都有自己的规划机制，而整个系统呢又能够通过不断的积累经验来整体变得更聪明。那举个例子啊，就像人类规划旅行，你先设定目标去巴黎，再细化为订机票、打包、订酒店等小计划，每一步呢都是一个子任务。那么完成之后呢，又能总结经验，让下次的旅行更顺利。那这就是加旦所设想的智能体学习方式，通过在计划中学习计划，让智能从经验中自然成长。
So here I want to pose two questions, and then any one of you guys can like answer any one of them if you wish. So one is on the abstraction and representation level, how much should we go beyond token level if we want to really generate longer kind of context intelligence? And the second, how much is it important to have a hierarchical structure in reasoning? On both questions,
Yeah, I do think that it's very important that eventually we look at hierarchical reinforcement learning in AI. The reason is currently, I mean, most of the signal are just a token level, and it's so low level, and this actually causes a lot of problem. I mean, for example, this causes a lot of problem of credit assignment and also data efficiency. So I do think this is very crucial that eventually we go to a higher level, go to a higher abstraction to look at something like subtasks, plans, modules, and functions, and do planning there. I think that if we eventually want to look at a very long horizon, I do think this is very crucial. And I also believe that if we do it correctly, it can significantly improve the data efficiency and also better solve the credit assignment problem.
Yeah, so I also agree that we need something like that at high level and combined with the token level. There may be a distinction though in the question that when we talk about the inference timed execution, right, at the end of the day, when the model produces the output, is still at the token level one by one, right, at least in the current framework. But I guess what I was trying to say to express is that this high-level thinking or high-level training may be needed in the post-training stage, where we set up the reward model, we set up the problem, right? And that's how we give a signal to the model to learn at the high level how to jump from local minimum to another better landscape of the policy space, as opposed to doing this narrow or local exploration at token level, right? But at the end of the day, and in the inference time, I think it's still probably we're still looking at a token by token level.
So I'm gonna, I actually like the direction that this is going, but I want to take it even further. So we as humans, when we want to plan to go to Japan, for example, from here, we don't think about the little muscle twitches that we have to make in order to make that happen, which is like go through the door and then take a cab and then go to the, take a plane. We actually think on a higher level of abstraction. We think about, okay, I need to get a cab from here, then take the plane, and then go to the hotel. And then you start bringing those back into a lower level decision. It's like, okay, if I want to take a cab, how do I do it? I call an Uber or a Lyft or something like that. And I think this is what I'm thinking currently LLMs are missing. We are thinking in the token level still, which is the muscle twitches of humans. And I think as you start going into bigger and bigger problem you want to solve, you need that level of abstraction in order to let you plan that far down the road. And the one way of doing it, which what Lihong just mentioned, is like when you want to do the backups, you actually think about further away decisions outcomes and then bring them back in rather than waiting for this to trickle through all the tokens. But one level higher than that is you actually have a policy actually thinks in a higher level, because we think that way. So we can have a policy to think is like, what are the chain of high-level things that I have to do in order to get to that outcome? Like I have to call this tool and then get the results filtered by that thing and then do something else in order to get to the reasoning that I want. And I think that's the way, currently there's not much work that I have seen out there, but I think that would be the direction to actually unlock the whole new era of reasoning available through these LLMs.
That's great. I want to add one question I didn't send you guys before. It's exactly on this line where, so when we're talking about hierarchical RL, and then also, especially when you're training LLMs, one of the things that people have tried a lot in training LLMs is to add process-based reward. And then if you want to do hierarchical RL to some extent, you have to have process-based reward. Like after you finish the whole, like 10,000 token long sequence, before you end, there will be checkpoints in the middle. Like, okay, after I finish this task, here's the reward. Next task, another reward, and so on and so forth. Would you guys think like it is really hard for us to really sort of derive some sort of process reward when we're training LLMs in the next like few years?
Yeah, I do think this is a very promising direction. I mean, definitely there are some challenges, but overall, I'm optimistic about that.
Yeah, I think that's interesting, promising idea to try. I think at some point, although right now I think outcome-based reward seems to go a long way, but I can imagine that in some complex problems, we need some intermediate signals. Even for now, I think when you call a long sequence of agentic calls, I think some recent work is finding that it's beneficial to have some intermediate signals, right? And also another point I want to make is that for these process reward or intermediate reward, they don't have to be final reward. It can be used as a solution or a technique as part of a curriculum training. We use intermediate reward at the beginning to guide the solution, to guide the exploration, and then eventually you take away the intermediate reward and only let the model learn from the final reward. So I think that's another possibility.
We actually recently looked at that problem very specifically. It's actually on arXiv if you want to read that paper, but to some extent it also depends on the model that you're starting with. Bigger models often have more power. So if you give them a problem to solve, they probably would find easier to a workable solution. Not the perfect solution, but they can get to somewhere that I actually see this verifiable reward at the end. Because if your model cannot see that good cookie at the end at all, then you can't learn anything. But for the smaller models, they might not actually be able to do that. So the thing that Lihong just mentioned, it is much more important for the smaller models to actually have access to a more enriched, dense reward so they can find their way out all the way to the end, a good end, versus as you go through the bigger model, they might not need as much as massaging in the beginning for the reward model to make it work. But the interesting finding that we had is one domain, but the smaller models, if you actually shape them well, you can actually get about 3 to 4 times compute saving and you get to the same outcome. So it's a balance of how hard you can actually work on your reward function to actually make it informative enough for the models to be able to tackle the problem. But you reap the benefits in GPU costs, which now everyone has limited resources of.
Yeah, and that also brings like importance in exploration, right? If you have like very sparse reward at the end, instead of just doing exploration, another way you could potentially do is probably adding more insightful intermediate rewards. All right, let's move on to a different topic. I think we've talked enough about how to train RL agents on LLMs, but I think we want to do a little bit more forward-looking. Where does RL really land us? So one of the things that OpenAI has brought up many years ago, probably not that many years ago, because ChatGPT wasn't out for that many years, is the level of intelligence from just a chatbot to a reasoner to an innovator and eventually become an organization. I think to some extent it's a product play, but to some extent as well, it is sort of showcasing the capabilities of LLMs and large models in terms of their sort of like capabilities scientifically. So the question to the panel is like, can the route of RL eventually give us the possibility of generating new knowledge and being actually an innovator through pure RL reasoning, or does that require a lot of additional data that's human annotated for this to happen? I think we've tried all orders, so we're gonna go back to the beginning. Lihong, maybe you can start.
Sure. Yeah. Great question. Yeah, I think it's possible, right, for RL to create new knowledge from without human labor, right?
Yeah.
And then as we have seen that, I think there is a success story where you let the RL system or model to explore in math, you can find new mathematical facts. So I think these are examples. But I just want to go back to an earlier point I was making that the ceiling of RL depends on how good the simulator is, right, or how good the model is. If the model we provided our system is in the form of the rules or just the knowledge we know about human know, I think at the end of the day, the RL can only explore raw knowledge or a new knowledge in this framework. It won't be able to create new physics theory, right, or new discipline. I think in order to go beyond that, I think we need something different, or something fundamentally different, probably.
Yeah, I do agree. I feel like, as Lihong has just mentioned, so RL is clearly depends on the model of the environment. Which more specifically depends on the model of the dynamics, the model of the reward. So I think that for domains or fields where we have relatively accurate environment model, and also suppose we do the compute in a reasonably correct way, I do feel that the RL paradigm can take us very far away. But there might be some fields where that either it's impossible or too costly to do some very accurate simulation. In such fields, and probably, RL is not the best paradigm to move forward. And we need to either use some available data set or thinking another paradigm to move forward.
So first I want to answer, I think AI has shown us already that it can do discovery beyond humans. If you follow AlphaGo, or you know move 37, it's like a move that the AI made that everyone thought with the 3,000 years of Go history, they thought this was a mistake. And then later on, it turned out that this was actually the winning move. So it was something counterintuitive, but it worked. And it aligns with what both Lihong and Zheng mentioned, which is if you have a good simulator, which in terms of Go it was, and also a really good reward function, eventually it can go beyond what every human is capable of doing so. And I think for LLM, we are changing the domain. We are going towards like understanding new physics and dynamics or like material, but the problem is the same. If you have a really good simulation that the agent can freely explore, go beyond what humans are actually providing, and also really, really good, rich reward function, I think it is very, very much possible given the past history that we have seen in this space.
Yeah, cool. So one of the things I do want to mention is like going beyond what we were just talking about on innovation is like this goes sort of back to the fundamentals of compute, where verification is fundamentally easier than sort of generation or creating solutions. So a lot of times that we're talking about verifications on these innovative systems, they are basically the simulator they want. Now, the additional question I want to add on here is there a possibility that we can go beyond like numerical rewards? Because in a lot of situations, like what Jen said, like verification systems or simulators of RL systems, they rely on a binary or numerical reward signal for us to be able to train an RL system going that direction. So is there a possibility that we can go beyond numerical reward system to be able to sort of like learn something smarter without like actually annotating with numerical rewards? This is a complete open-ended question, so feel free to skip if you don't have an answer for this.
I have a question for you, actually.
Yeah,
what do you mean by non-numerical rewards? At the end of the day, we're doing all this matrix multiplication at scale. So
right. So like you can think of like, for example, the probability of distribution of words, like on the token level, they're not technically reward, right? They're basically probabilities. Can you leverage those kind of like probability distributions as a guidance for you to train an RL system instead of just like using like one final reward at the end as a reward signal?
So I can start taking a crack at it. I'm Rich as a student. From Rich's perspective, everything has to come down to a singular numerical reward function. And there is a really interesting podcast with Rich. I highly recommend go listen to it. But other people say, hey, we as humans, we have a lot of things that we want to maximize. We have family, we have work, we have career inspiration, we have like, I don't know, fun, hobbies. How all of those become one single reward function? And his answer is like, maybe there is a single thing that we want to maximize, and it just shows itself in various ways in our life. And his belief is that for the agents, it's going to be the same thing. If you find that what should drive the agent, all of these amazing behaviors would actually emerge from that maximizing signal. But to your question, maybe some of these can come from preference. Maybe we cannot put a point that is like, how good this is, it's 0.7. We don't know. But if you ask enough from people, it's like, hey, is this one better than that one? We know that humans are much better in that job compared to give you like, how good is this summary? And maybe we can then walk backwards from that and, for example, extract that.
Jen, you want to take a quick stab at it?
Yeah, I kind of agree. I think there do have some settings in which we think the reward should be a vector or a reward should be a probability distribution. But for the current paradigm, eventually, I mean, if that's the case, it seems you have not finished your reward model. And somehow you need to convert the vector or the probability distribution into a scalar so that you can optimize. I do want to mention an exception. Is in multi-agent reinforcement learning. You can think each agent has its own reward. So in this case, you can think the reward is a vector. And also in such settings, you will deal with notions like Nash equilibrium, I mean, which is a little bit different than just doing optimization.
Cool.
Yeah,
All right.
Briefly, I think numerical rewards, I think we need that, something like that. But on top of that, I think maybe multi-dimension of numerical rewards.
Cool. Yeah, that goes to a lot to the generalized file function stuff as well. Yeah, I just want to throw one creative question out there so that there's actually a discussion then, pre-thought of answers. All right, so we're almost out of time, so I want to spend the last few minutes trying to like ask each panelist about where do you guys think the most near-term kind of advancement that RL can bring us, either on personalization, scaling, or just any AI system advancements you will see from RL in the next year or so?
Since I spoke a lot, I think the abstraction is the way to go. I'm very passionate about it. I think it's going to give us a lot of goodies coming.
好，在这里呢，我们再快的解释一下 Gary 福尔博士说的抽象 abstraction 是什么意思。那么在强化学习 RL 当中呢，环境往往是高维的、连续的或者是复杂的，比如说一个机器人视觉输入的像素、金融市场的多维数据，或者呢对话系统的上下文。所以呢，他们这里说的 abstraction 的目的就是减少状态空间、行动空间或者奖励结构的复杂度，使 agent 能够学习到更通用的策略。那么换句话说 ，abstraction 就是在保留任务核心信息的前提下，丢弃无关细节。
Actually, I have the same answer. I mean, I think hierarchical reinforcement learning and abstraction is the way to go.
Yeah, on top of that, another direction I think may be useful to look at is or fruitful is how we can learn from more diverse data, not beyond verifiable, and LLMs are just kind of reward signals.
All right, cool. That's everything we have for today. Thank you guys so much for the attention, and hopefully you guys learned something for today. Thank you, guys.
Thank you.
Right. Thank you, Bill. Thank you, gentlemen. Thank you so much.
好了，那么以上就是这场强化学习 panel 的全部内容，非常的干货，非常的前沿，非常的硬核。那这3位嘉宾以及主持人 Bill 朱呢，都是在强化学习领域多年的一线研究者啊。那么在现场不少的行业内观众给我们的反馈都是，哇，我居然在现场看到了从前只能够在论文中才能读到的名字。那听到他们对 RL 的讨论真的是太酣畅淋漓了。所以呢，这一场的内容啊，是我们一定想要分享出来给大家的。 那我知道呢，这一期的内容对于非 AI 专业的观众来说呢，会非常的难以理解。就像我其实在现场听着也是觉得太难了，听得云里雾里的。但是回来之后呢，我也是看视频回放看了好几遍，把不懂的专业词汇边听边问 AI 工具，才能够把整个对话给顺下来，也是非常难得的学习体验了。所以呢，我也建议对强化学习和 AI 感兴趣的小伙伴们可以多看几遍，同时呢，用 AI 工具把所有你没有听懂的术语问清楚，也是一次很好的思维训练。我自己呢也是非常享受这个过程，也希望大家觉得有所价值。那我们大会的内容呢，还有另外一场关注 AI 和教育的讨论，我们会随后的放出来，大家记得关注我们，不要错过更新哦。那我们就下个视频再见啦，拜。